This is Unit 3.2, Algebra 3. We're talking about measures of central tendency and variation. Here is the slide where we left off. This is going to be part 2 of the notes. We talked about standard deviation. It is a measure of how spread out a data set is. This is the sample standard deviation, which is the square root of the variance. This is a complicated formula, so we're going to copy this. And we'll use it for example 1. You roll a die 6 times and record the numbers for each roll. Find the sample standard deviation. Suppose that we roll a die and we roll a 1, and then a 2, 3, 4, 5, 6. Those are our outcomes. It's probably not going to happen. We're probably going to roll it, and then we're going to get 2 3s, a 4, a 6, and a 2, or something else like that. But we're just going to keep it nice and organized. Alright, if we want to find the mean, I'm just going to add those up. And then divide by 6, and that should give us 3.5. Okay, there we go. The second column, I'm going to take each x value and subtract 3.5. So 1 minus 3.5 is negative 2.5. 2 minus 3.5 is negative 1.5. And so on. Remember that when we sum up this entire column, we should get 0. That's how I know I've done it the right way. It's also not a good measure of how spread out a data set is because the sum is 0. So instead, we're going to square each of those numbers. Negative 2.5 squared is positive 6.25. Negative 1.5 squared is positive 2.25. And so on. Now I'm going to add up that column and get an answer of 17.5. This is a really important number. This is the sum of the squared deviations from the mean. It is also the numerator in our formula. So this table helps you organize all of the information as you're calculating it. So let's bring it down here, and we'll write the standard deviation. Sample standard deviation is the square root of 17.5 divided by 6 minus 1. Because remember, with a sample, we're subtracting by 1 there. And that'll give us an answer of 1.87. This problem is now complete. This is also a good opportunity to demonstrate how to find that answer using the graphing calculator. Let me bring up a calculator. Here we go. I am going to put this data set in under L1. So let me press Stat and then Edit. Put the data into the calculator. There's my list. And then I'm going to press that Stat button again. But this time, let's go to Calculate, and let's get one variable statistics. Really great function. Our values are under L1, and let's tell the calculator to calculate. there you are. Notice that the sample mean x bar is 3.5, so we're correct on that. And then that SX says 1.87 with a bunch of decimals. That's the sample standard deviation. The one below that says sigma, lowercase sigma x, 1.707 and so on. That's the population standard deviation. I could obtain that number if I took the same thing and divided by 6 instead of 6 minus 1. So 2 ways to calculate it. Do it by hand, check your work with the graphing calculator. We will skip over this activity about measuring height. However, I will tell you that if we were to plot everyone's height on a graph and make a histogram, it would be symmetric. Furthermore, the shape would look exactly like a bell curve. That's going to be true for height. If you took data from any random classroom and you measured everybody's height, you would get a picture that looks pretty similar to a bell curve. We will see this later on when we talk about what's called the normal distribution. Okay, right in the middle would be our average height, x bar. This is frequency. And then, why are we talking about standard deviation along with this curve? Well, standard deviation is going to be a measure of how spread out the data is. So that's going to be one standard deviation. That's going to be another. So it's the distance from the mean. Okay, next example. Use a graphing calculator to find the mean and standard deviation of each data set. At this point, I encourage you to pause the video, try A, B, C, and D, find the sample mean and the sample standard deviation for all of them. All right, here we go. Part A, the sample mean is 15. The sample standard deviation is 0. This makes perfect sense because all of the values are the same. So there is no variance in the values. Graphically, this would be a histogram with just a single bar. The data is not spread out at all. Part B, the sample mean would be 4, and the standard deviation would be 1. Now, take a look at this data set. The numbers are evenly spaced out from 4 to 3, a distance of 1. So 4 is right in the middle, everything's evenly spaced out, and the standard deviation is 1. So it'll rarely happen that the standard deviation is a nice number. It's just comes out nicely. But we're just showing you to demonstrate how that works. Look at C. This would be a histogram that would look like this. 2's on the left, 6 in the middle, 10's on the right. Perfectly symmetric. So the mean is going to be 6, and the standard deviation, you should have gotten 4. Finally, part D, the mean is 20, Standard deviation is 2. Below, you have instructions for using the graphing calculator, what we did before. All right, and then there's one more topic we want to discuss. There's one more way to measure and compare deviations. And this is the coefficient of variation. The coefficient of variation compares standard deviations of 2 or more data sets. It is given by CV equals the standard deviation divided by the mean times 100. So we're just sort of making it a percentage there. And we're going to be able to compare 2 different data sets. So, you survey a group of high school students and find that the standard deviation is 20 pounds and the mean is 150. Then you decide to survey the football team and find that their mean weight is 190 pounds with a standard deviation of 30 pounds. Which data set is more spread out? Let's compare the coefficient of variation for the students with that of the football team. So for students, we get a value of 13.3 repeating. The coefficient of variation for the football team is 30 divided by 190 times 100. And that's 15.78. What we want to say is that the coefficient of variation for the football team is greater. So the data for the football team is more spread out. You might have players on the football team that are really skinny, like wide receivers. They have to be fast and skinny. And then you might have players that need to be really hefty, and they like to eat, and they're linemen. So there's a lot of variance in the weight of football players. There you are. Please comment on this video in order to earn credit, and then have a nice day.